Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. So for this class, we go to the chapter 4, Introduction to Probability. For the learning outcome, by the end of this topic, student will be able to first define the basic concept in probability. Second, you will be able to apply the probability rules in some example. And last, explain and apply the Bayes theorem. For the content, first introduction, we have counting rules, multiplication rule, representation of sample space, and last Bayes theorem. So we go to the introduction first. This is the meaning of the term in probability. We look at experiment. What is the experiment? Experiment is a well-defined, repeatable process where outcomes are determined by chance. It is a process of making an observation or taking a measurement. For the outcome, the result of the trial of a probability experiment. Sample space, we denote by S the set of all possible outcomes of a probability experiment. For example, the experiment is rolling a dice once. Sample space is 1, 2, 3, 4, 5, 6. For the event is a subset of sample space or any single outcomes. Elementary or simple event, single outcome in a sample space. We have two events, which is first elementary or simple event, second compound event. Compound event is more than one outcomes. Sampling with replacement. Each time a sample is selected, it will be written into the population before the next selection is made. Sampling without replacement. Each selected unit will not be written to the population. For example, 4.1, page 100. We have experiment. A medical researcher lists the possible sex, M, male or female, of each of the first 3 babies born in an animal laboratory by order of birth. A. List the sample space of the experiments. We have male, 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 or M, male, male, female, or M, female, male. So F, this is the sample space for the 3 babies born in an animal laboratory. And B, list the event A if A be the event of obtaining 3 females. From this sample space, list the event A if A be the event of obtaining 3 females. Which means female, 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 F, F, F. The solution is F, 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 simple event or single event. Next, C. List the event B if B represents the event of obtaining at least 2 male. At least 2 male. Okay, so look at the sample. 2 male, 2 male. So MMF. So the answer, we go to the answer MMF. So MFM, 2 male, and 2 male, FMM, and 3 male, 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 which is compound event. We have more than one sample. 1, 2, 3, 4. Next, Venn diagram. So Venn diagram provides an easy and useful method for picturing the relationship that exists among events. So we have 4 types of diagram, which is complement of A complement A prime. Outcome of event A does not occur. So this is area outside the A is a complement. A here. The outside of A is A complement. We go to the intersection of event A and B. So we denoted A and B. So A and B. So we use this symbol N. So A and B outcomes were both event A and B occur, which is here. Union of event A and B, denoted by A union B. We use this symbol. So A union B, it means all of A and B. Outcomes of either event A or B or both. A or B or both of A and B. So last one is mutually exclusive. Event A and B have no outcomes in common. Next, example 4.4, page 103. Okay, read a example question. A health product consists of 3 types of ingredient, namely P, Q, and R. Okay, we have P, Q, and R. A defective product can be due to the contamination in 1 or 2 or 3 ingredient. Out of 210 defective products, it was found that 125 was due to the contamination of P, 85 due to Q, so this is a information given, and 100 due to R. From the defective products, it was found that 60 has exactly 2 contaminated ingredients, of which 24 was contaminated in P and Q only, and 16 was contaminated in P and R only. The question is, draw a Venn diagram to represent the above data. First, draw the Venn diagram P, Q, and R. So this is R. So from the information given, 125 was due to the contamination of P. P 125. Q 85 and R is 100. From the defective product, it was found 60 has exactly 2 contaminated ingredients, of which 24 in P and Q. P and Q here. P and Q here, 24. And 16 was contaminated in P and R only. P and R here, 16. So the remaining is 20 here, C and Q. So B, find the number of defective products that are due to contamination of all the 3 ingredients. So we have to find the D here. Okay, so the probability is P, and Q and R. So here, find the number of defective product. So A plus 24 plus 16 plus D equals to 125, which means P is A plus 24 plus 16 plus D equals to 125. And for Q, B plus 24 plus D plus 20 equals to 85. And for the R, C plus 20 plus D plus 16 equals to 100. And A plus B plus C plus D plus all of this value equals to 210. So how to find the number of D here? We use the simultaneous equation. And we got D equals to 20. So lastly, find the number of defective product that contain exactly one ingredient that is contaminated. So we have to find the value of A plus B plus C. From the information given, we use the simultaneous equation. We get A equals to 65, B equals to 21, C equals to 44. So the question is find the number of defective products that contain exactly one ingredient that is contaminated. So we plus A plus B plus C equals to 65 plus 21 plus 44. Okay, press the calculator. 65 plus 21 plus 44, which is 130. So the answer is 130. Basic concept of probability. Let A be any event defined over sample space S, then the probability of event A is PA. Number of outcomes where A occurs, and we denoted NA over total sample space, NS. The probability must be in 0 to 1. And PA equals to 0, event A is impossible to occur. PA equals to 1, event A is certain to occur. PA plus PA complement equals to 1. And P and B, PA and B, and A and B over NS. So this is exclusive, mutually exclusive. PA and B equals to 0. Here the formula is PA and B equals to PA times PB. Event A and B are independent event. Event A and B are independent event. If event A and B are independent event, so PA and B equals to PA times PB. Addition rule, union of event. PA union B equals to PA plus PB minus PA and B. If event A and B are mutually exclusive, PA and B equals to 0. Okay, mutually exclusive like this. A, B. No intersection between A and B. PA union B equals to PA plus PB. If event A and B are independent, so PA and B equals to PA times PB. PA union B equals to PA plus PB minus PA times PB. Next, example 4.6, page 106. Given that A and B are two event A which PA is 0.6, PB is 0.35 and PA and B is 0.2. Find A union B. So A union B, we use the formula addition rule. A union B equals to PA plus PB minus PA and B. So we use formula, the addition rule, 0.6 plus 0.35 minus 0.2, and we got 0.75. Or we use this formula, 0.4 plus 0.5 plus 0.15. So for the B, A complement union B. So A outside the A. A complement is the outside the A. And B. So intersection here. The area of the intersection is B. So PA complement equals to PB minus PA and B. Okay, so PB we got 0.35 and minus PA and B 0.2 and we got 0.15. For the C, PA complement and B complement. So A complement here, the area of A complement here, and the B complement here. B complement here. So from this area, from this, we have intersection area is the outside of A and B, right? So for the calculation is 1 minus, for the calculation is 1 minus PA union B. Okay, we got 1 minus 0.75, we have 0.25.